Hi everyone, I'm Janice and welcome to our podcast series on tidying up HACCP with Rolf Ace. Rolf is well known in the food industry and has traveled extensively and has audited thousands of HACCP studies. In our first two episodes of this series, we looked at the application of principles 1 and 2. Now we look at principle number 3. And this is all about determining your critical limits for your CCPs. And we look again at the struggles food safety teams have in getting this right. So hi Rolf and welcome.
Hello everybody. Yes, nice to speak again. So yes, this is a very important part of HACCP. One has now determined your CCP. Now one has to follow through properly through setting the right critical limit, and then from there on monitoring and corrective action and all the other stuff.
Okay, so now we've determined our CCPs. So just a quick recap on that. Those are your pasteurization steps. It could also be a metal detection step. And we've validated the CCPs. And now when we apply this next principle, number 3, ISO 22000 clause 8.5.4.2 requires that we also need to apply everything that we're doing here to our OPRPs as well. And of course, we're talking about critical limits here and establishing your critical limits. So we've got to look at our OPRPs as well as our CCPs here. Rolf, can you quickly give us an overview of how we could do this with our OPRP and our CCP?
All right. So a critical limit is the difference between safe and unsafe. So we need to set a limit, and you can't manage what you can't measure. So you accurately need to measure and then set the limit where it's safe or not. Now this will be determined again. It's part of your validation studies, literature, trials, those kind of things will determine your critical limit. So in other words, for a pasteurizer, you look at the capability of your equipment, the pathogens in your product, and you'll set your time and temperature level at that pasteurizer as the critical limit at a level of, so let's say 63 for 10 seconds. And it depends on a lot of things. I mean, the water activity of the product, the pH, and so on. So point is, we need to set it properly, and that's the difference between safe and unsafe. Then for a OPRP, such as a sieve or a magnet or a temperature control step, like a fridge and so on at the raw material stage, that's been defined as an OPRP. We can't again call it a critical limit because it's not a critical limit. If you exceed that limit, it's not unsafe. So that they call now an action limit. So the methodology of controlling it is the same, and you'll get somebody to monitor it, and you'll take corrective action if it's not being met, but it's not necessarily unsafe.
Okay, so we've got the critical limit for CCPs, and we've got an action criteria for OPRPs, and the critical limit, if that is exceeded, then we will have unsafe product, and an action criteria at an OPRP, if that is exceeded, then we could possibly have an unsafe product, but not definitely.
Correct.
Okay. Rolf, what are some of the mistakes that you've seen food safety teams make when it comes to determining critical limits and action criteria?
First one, I would say, again, to do with practicality, is making impractical limits. So now let's take the metal detector as example. Setting the critical limit as 2 millimeters on the test piece, but it's an old metal detector, and 9 out of 10 times it can't detect 2 millimeters because the aperture is wrong and the characteristics of the product are wrong. And then essentially HACCP doesn't work because we're not monitoring properly, haven't got the right critical limit, then it's just all goes pear-shaped. So practical limits, rather go a bit larger. You use a 4 millimeter test piece, and that you can detect, and that's critical. And then the smaller pieces of metal you control through magnets or better preventive maintenance or that kind of thing. So just being practical on your critical limit. Just another example would be there on let's say pasteurization. The critical limit isn't the 63 for 10 seconds that the computer is monitoring. The critical limit is actually that the divert valve is working. So it's if we fail the divert valve, then we'll have unsafe products. And it's not what the computer is doing in the critical limit that's theoretical on the computer. It's something a person does, and it's something that should be real.
Okay. So when we look at the ISO 22000 standard, it requires that we need to document the rationale behind the selection of our critical limits and action criteria. Does this mean that we actually have to validate the critical limits and action criteria? Do we have to do this, and how do we go about doing this?
Correct. Yes. So one can't just work on assumptions. You must work on scientific data. So you look at the correct characteristics of your product. And this, again, team approach, multidisciplinary team with all the right experts. If you don't have the right expertise, get external help. But then deciding on these things, what is our critical limit? How did we get to that? And document the decision process, or refer to the literature on how one got there. And then, like I said in the previous podcast, learn from your mistakes and your previous data. So if you're getting decent results at a certain critical limit, then you'll use that to make decisions next time.
Great. Another term that is used is the term acceptable level. Can you maybe give us the difference between this term acceptable level, action criteria, and critical limit?
Right. An acceptable level is something you look at after the hazard analysis. So once you've done your hazard analysis and you're at micro levels, for instance, what would your acceptable level be for hazards at that stage? So it's not yet a CCP or anything. It's still the early stage to do with the hazard analysis. A critical limit is now the absolute limit when you now have decided on CCPs. What are the limits on that CCP? So it will be a time, a temperature, metal detector, test piece size, chlorination level, that kind of thing. An action criterion belongs to an OPRP. So it's the measurable at the OPRP and where you'll take action. So at your CIV, let's say, your action criterion will be, it has to be intact and it has to be in place. Now, and it's not always a numerical value. It can be a positive or a negative, like in that instance. Yeah, that generally would be the difference between the three.
Okay, so the acceptable level has got to do more with the hazards in the product, while the action criteria and critical limit is more related to the process.
That's right.
Rolf, we understand that both critical limits for CCPs and action criteria for OPRPs need to be measurable wherever possible, but sometimes these can't be measured. And the BRC standard says that where these cannot be measured objectively, then we can look at subjective parameters such as sensory parameters or visual appearance and texture, as long as we support this with clear guidance, such as the use of photographs of acceptable and unacceptable limits. Can you perhaps give us examples of where subjective parameters can be used as critical limits or action criteria?
Yes. So a good example would be poisonous seeds in the nuts and pulses industry. That's something that could affect health, and one needs to know what that looks like. And you'll put photos up, and people will physically check for that. Also, it's something like, I mentioned it earlier, at an OPRP is your action criterion there would be in place intact. Or at a magnet, you would have, is the magnet actually there? Is it working? Is it being cleaned often enough that there's no metal buildup that could get into the process? So all of those aren't something physical. It's got a number. It's something subjective. And like you say, photos and guidance and training is key there.
Can a critical limit have an upper and a lower limit or a range? Or is there only
Yes.
one limit that needs to be measured?
So sometimes it only has one, like pasteurization, it's got a minimum. But let's take, if you, the fresh produce industry, and you chlorinating your fruit and that kills the E. coli and the pathogens, then you'll have upper and lower. And for instance, and you'll also have target levels. Now, so your target might be 1 part per million. That's what we're aiming for. Upper limit, it would be, let's say, 5 ppm or 50 ppm. And if we exceed that, we start getting chemical taints. So we can't exceed that. So we need to limit it on the top. At the bottom might be 0.5. And that means if we exceed that, it's unsafe. And that's the bottom one would be your critical limit. So yes, there could be a upper and lower critical limits.
So the target level would be used as a level just before the critical limit as a buffer, so that it would help you make sure that you action whatever you need to do in order to rectify the process before you get to the critical limit. Is that right?
Correct, yeah. So when you're driving with your bicycle on the cliff, you don't go as close to the edge as possible. You go as far as to the edge as possible. So same here, you're aiming at your target level. There's sometimes a range that that you start taking action, and then you steer clear from the critical limit. Yeah, the other way of seeing it is, if you exceed your target level, you won't necessarily take corrective action. But if you exceed your critical limit, then you'll hold product, you'll process the hazard out, or you'll reject the product. Where for target levels and getting out of control at ranges, you won't do that.
Okay, that's great. So let's wrap this up with some key takeaways from this episode when we spoke about determining critical limits and action criteria, principle number 3.
I would say first one, as I said in the other podcasts, common sense must prevail. So make informed decisions with all the right data, and do things for the right reason, and don't do silly verification validations just to tick a box. Understand the difference between the action criteria, the acceptable levels, and the critical limits. And then a person must do the control, not a computer. So make sure that there's always a human element. What must the person do to control, not what does the computer do?
Thanks, Rolf. That was great, and we look forward to the next podcast where we discuss the application of the 4th HACCP principle with you. Mail us at info@intercom.co.za to subscribe to our podcast, videocasts, and ebook, where we give you loads of free information to help you with your food safety systems.